Welcome to the 10th episode of the Great British Design Podcast. Hello, everybody. Welcome back to the Great British Design Podcast. My name's Nick, and I'm joined by Harry Ray and Andy Smith.
Oh,
How have you got? And before we start, I guess we'll go on to what we're going to be talking about this week, which is design for manufacture. That's our topic of the week. You know, it's all well and good mocking up some CAD models and some nice renders, but you want to get it in the market, right? You actually need to get it made. So quite an important part of design. So that's what we're talking about today. But how have you guys been doing?
Not bad.
Okay.
Tell us about your week.
Me
Harry?
first.
Yeah, you first, Harry.
Go.
Busy week.
I've done some bits and pieces.
Some bits and pieces.
Well, yeah, I'll say first of all, I got a new job. I got a new job offer, which is good. I probably won't talk much about it because I don't start for a month. So
Yeah, that's fair.
well, we could talk about it more when I've done it for a week or so. But that's good, very exciting. I got delivery of my iPad, so I've been playing around with that a little bit, which is very nice. I've wanted one for a very long time, and now I can have no more excuses about not doing any drawings. But I got that. And as for projects, I have ordered about 80% of the electronics for my 3D printer project. So as I ordered them all on eBay, they will be arriving in the next 3 months or so, spread out. There'll
be one that's delayed for ages as well.
Oh yeah, and it'll be
the most
important,
important one, yeah.
So I've been doing some 3D prints of all the little brackets and stuff that I'm printing with our other printer to hold all these bits in place. But as there was no individual store for me to buy all the stuff from at any sort of good value, I had to literally... My emails have been spammed of all the individual places shipping all the individual components that are all from different stores, which is kind of annoying.
Oh, no.
But
No.
I should have enough time now to print all the bits I need. So when all the bits come, I can start assembling it, which is very exciting.
Very nice.
Hopefully it works.
And is
That'd be
this
very
your
sad.
first YouTube video, is it, Harry?
Well, I mean, I'm definitely going to record it.
Yeah,
Whether
that's what I like to hear.
people will see it, I don't know. But
Yes,
at worst
they will.
case, it will be a good second test for videos and what I need to make a video to a standard that I would like. Because I recorded a load of bits before for the casted plant pot project that I was doing, and I just didn't get enough shots of me doing it. There was so many gaps in all the stuff, and it just wasn't good enough. So take 2 this time. We'll try again with a more detailed shot list, I think. That's my plan.
Sounds good.
That's
Sounds
good.
really
Good
good.
idea. Good idea.
What
Has
about
that been
you?
your week? Is that
Yeah,
Yeah, is
I
that
mean,
rounded up?
Oh, wow.
I think so.
Quick.
I've done little bits and pieces, made some leather stuff, leather things, but nothing too crazy really. I just sort of been, since I got the new job, just been looking at loads of stuff about that, to be honest.
Research.
Yeah,
Are
all
you
the research.
going to be putting any of your products on your website anytime soon? Or is that in your level working products?
Oh,
Is that
I
in the near
actually...
future?
sorry, I forgot. For the website, I always started the first of the 2 blog posts for the 3D printer. I've written pretty much a full blog post on how I did all the steps of designing each part. Not to crazy detail, because a project like this 3D printer could literally be a dissertation if I wanted it to be. But basically, had gone through the reasons why I chose each aspect of the design, which is kind of cool. So that will be up soon, and then there's going to be a second one, a follow-up one of the building it and all the things I come across with building it. So we're doing that. And yeah, because I made a few watch straps and stuff, and I think they'll be going on my website, all with a plan to potentially sell them at some point. Whether it's actually going to be on the website or in an Etsy page, I don't know. But I would kind of like to try and sell some things, or at least have some things that people are able to buy. Not that it'll be particularly successful first, but you won't. It definitely won't be if I don't put anything out there. So
That's very true. Got to get it
yeah,
out.
no,
if you
just,
want to sell it.
just that sort of thing. So I actually bought a massive sheet of leather for me to make like 20 wallets. So that'll be a weekend task at some point when that arrives. Yeah,
Got
just a
loads
bit
of
of
cows
fun.
in the garden.
It's what I sort of do to sort of switch off, which is not on my computer, which all my other hobbies are on a computer. So that's sort of what I do that for.
Question
Sounds
is,
good. What about you, Andy?
did either of you guys keep track of waking up early? Because that was on the old last podcast.
That was.
I was meant to ask you guys that.
That was.
Yeah.
So, I mean, my last week, I got up early every day, and then this week, Monday, it just went to pot, and then Tuesday again, which is today. No,
dear.
didn't happen. So it lasted a week. What about you guys?
Go on then.
Pretty much the same as you, to be perfectly honest, Andy. Last week was good. I've been waking up early still, so I've been waking up at 7, getting out of bed, getting my phone, putting it on my side table, getting back in bed, going, still pretty tired, you know. And then one of two things happens, I guess. Either I'll listen to the audiobook that I've got recently, or I'll just fall asleep and wake up at 9 o'clock. That seems to be a trend as well. And yeah, it's hard. It's really hard to actually train yourself to wake up early again.
It's
Yeah.
just like
Especially if you've been doing
the
it for like a
pure
year.
battle of wills, isn't it? It's
Mm.
what part of you is stronger? I want to be productive, or my bed's pretty comfortable.
And
Which one
they're
is-
both solid arguments.
They're both good arguments. Some days it's not even a choice though. I'm just still in bed, and it's fine. But I did okay. I had see, the main issue I seem to be having is some nights I just can't sleep at all. It's probably mainly because I only do my workouts after midnight, because time runs away with me, and
Yeah.
I'm like, oh, it's 11:30, and it's on my to-do list to do a workout, so I guess we're doing a workout. And then I always seem to find the days that I do a workout at gone 12, I don't wake up very easily. I wonder why
Not
that's
surprising.
Makes sense, yeah.
Yeah, so I think that's I need to get on top of that before I can reliably wake up early, to be honest. But
For me, I've got a housemate that leaves for work at 4 in the morning. So I usually get woken up by the front door. And then I have another housemate that will leave to work at 6 in the morning. And I get woken up from that. And I'm just I'm not getting any like really good sleep all night just because I get being interrupted constantly. So when
That's not
my alarm goes off at 7, I'm like, oh man, I'm so tired.
yeah,
Let's just get back into bed.
Sounds like a 4 a.m. run is on the cards.
Yeah.
yeah. Why go back
I-
to sleep?
Yeah,
That's fine.
you're
If I
right.
just went to bed at 8 and then woke up at 4 with him and then go for a run, I mean, that would solve all my
could.
problems.
You could.
I wouldn't, but
I-
you definitely could.
I was actually thinking about this, of like why you see all those YouTube videos of all these big successful CEOs and successful businessmen always wake up at like 5 in the morning or even before. And I always think it's because they've got kids, right? It's literally that.
be.
They can't stay up late.
They can reply to a
Because-
lot of emails and stuff
Yeah.
before other people are awake as well. My dad often starts work like an hour or so before all the people he works with, so he can get loads of stuff done in those at that hour, and then when everyone else is awake and there's endless distractions, he knows he'll get less done. So I think that's why a lot of these people get up super early, because they can just do like a day's work in the time before people are actually
Yeah,
up
3
and doing
hours.
stuff.
A couple of hours, yeah.
But I mean, the whole kid argument is also a good a good help for that. Your kids, you'll be going to get to bed a bit earlier, and then you'll be up.
Yeah, because I think like if you stay up late, your kids are more likely to want to stay up as well. Well, if you're like, okay, I'm in bed at 8, the kids have to go to bed, and then you wake up at 4 or whatever, and then they still wake up at like 7, 8 or whatever, and you just have that additional time.
Definitely. So that's what you're doing next week, Nick. You're waking up at
it's like it. So you get 3 hours
Well,
on your
next week-
next project.
I'm glad we agreed that, actually. That's good.
Oh, I can get up at 4. I'm struggling to get up at 6:30.
It's hard. Well, next week I have to get up early because I start my new job.
Ah,
So I literally
yes.
have no choice. So, or probably lose my job because I can't make it in on time. One or the other, I suppose. So,
That's going to be a
the
bit
new
of a shock
guy
for
who
you.
can't
it's
get
going
in
to be
for
a
8
definite
o'clock.
shock. Yeah, strict hours
Yeah.
now.
And I cycle as well. I can drive, but I just prefer cycling. So it's like a 35-minute cycle. So I have to leave at like, let's say 7:15 to get there at a good time. Well, to get there so I can actually calm down a bit, wipe the sweat off my face, try and do my hair a bit. Or I can leave at 7 and give myself even more time. But that means I have to be up even earlier because I have to have breakfast and like a cup of tea in the morning. I can't work without breakfast or a cup of tea.
Oh, damn.
So that's like a priority. It's tough.
You wouldn't be very good at intermittent fasting then.
Probably
So,
not.
yeah, I'm
I mean, I
not-
could train myself to not do it, but it's been a habit for so long. Like I have to do it.
Yeah.
Need that good cup of Joe in the morning, right?
Agreed. Andy,
Oh, I missed
what
out
did you
on
get
mine
up to?
today. My coffee
did you
today,
get
I
up to?
missed out. So my one tiny project that's been going on for a few weeks is my basketball tea mug project. I've written it down. So I've got a CAD model for it, and I finished it off. I could actually
nice.
show you guys after this, but I wanted
I wanna
it
see.
so very minimal effort needs to go into like any mechanisms or anything, not like minimal parts. So basically what it is it's a coaster with a pole which you then put another pole into, like a flag pole, which then has the backboard on it, which is curved to be like the mug, and then there's like a little bit that sticks out at the bottom of that of the backboard, which would rest on your mug, so you can do it at any height. So if you've got like the tall Sports Direct beasts or a little mug, just a little standard stir, then it'll work.
The Disney American size ones.
Yeah. So and throw it in, and it's a good time.
Nice.
Damn.
So yeah, that's mainly what I've been doing. I mean, I've obviously been trying to get up early, like we were discussing. That went well last week and not so well this week, so I need to get back on that. And that's honestly it.
Really?
I have done absolutely nothing. Yeah,
Yes, all right.
edited the podcast. That's my weekly
I
to-do
mean,
list.
it's a lot of work, to be fair. Like,
It's a fair.
you're smashing it.
it's
And
a
I think
fair
they've been
amount.
edited brilliantly. To be honest, I've had some good laughs watching through the podcast again, so I've been enjoying it. Especially that dance. Was it 2 episodes ago now? I think it might be.
It
2
would be,
episodes
yeah, depending on
Episode 8,
the situation with the last one. Yeah.
Yeah, we had some issues with our last podcast, but we'll see. Yeah, I mean, for me, I've got work to do. I've had freelance work to do this week, and I've had to negotiate hours and things like that. It's been a bit of an awkward conversation, but it's been okay. And just been preparing to go back into full-time employment. Really,
Ooh.
I've been kind of researching the products that they have so I can know the portfolio, and brushing up on my old wood stove regulations. Oh, fun.
Ooh,
Oh, that's been good. So
love that.
I've made some progress on my desk organizer.
Oh,
I've
this
actually
is
done some
this is
concepts
what we're waiting
now.
for. I think
Yeah,
even
I've
this
actually
bit
done
needs a
some, like,
jingle.
proper
This is what everyone
concepts.
tunes in for at this
Yeah,
point. Nick, is
exactly.
Yeah.
to see what this
I-
glorious thing is going to look
Next
like in the
weekly
end.
project. No.
What's that? Weekly project.
I was saying next weekly project is going to be the little tune.
Weekly projects jingle.
On this weekly project, we're doing the same one as episode 3.
I have actually. I've given myself more projects that I want to do, but I do need to finish this one first.
You just need to stop giving
I'm
yourself
planning ahead.
deadlines. You should just say, this
Yeah,
is my
yeah.
new project. Like mine
It's
could
nearly-
easily be done in a week if I had a week's worth of
Yeah.
time.
I've decided they're not weekly projects. I think that was a bit ambitious, and especially I'm going to have less free time now. So
Yeah, it's like it's a weekly project if you've got nothing else going on, then that's
Yeah.
fine. But you know, with
Exactly.
work or freelance stuff, you've got to prioritize that. Unfortunately,
Yeah, I mean it's a shame because it's really fun. It's kind of what I want to do, just design my own stuff and have complete freedom. But then sometimes that can be a bit overwhelming, and you kind of go, oh, I like this, and the next day you look at it, you go, not why did I think that was good? And then the next day
Terrible
you
idea.
then think the one before that wasn't so good, and then a week later you think your first idea was pretty decent actually. So
oh yeah,
and then
I'm like that.
so I think it's just kind of choosing an idea and going with it and then improving it. That's kind of my plan, I think so.
Cool.
But yeah, I mean, I've not really been up to. Apart from that, it's been pretty chilled out. I'm looking forward to getting back into full-time employment, to be honest.
It's going to be a pretty big change for you.
because
You will be.
It will be. I
been a
think it's
while.
gonna. I think I'm gonna be knackered for about 2 weeks, to be honest, because I've been sat at home for like a year, right?
Yeah.
So it'd be interesting to
Yeah,
get back
yeah.
into the office. And also this where I'm working, it's when I start, I believe it's going to be 5 days back in the office.
Mad, yeah.
I think currently it's 4 days in the office. Or obviously this week is bank holiday, but next
Is
week
it?
I think they're trying to get everyone. Well, yeah,
Oh man.
we got Friday, Monday off, right? So
Oh, that bank holiday. Yeah.
yeah.
You're thinking it's
And,
May already, Harry?
I couldn't even tell you what month we're in. I'm gonna be honest with you.
Well, I guess Easter weekend, right?
Easter,
Easter
is coming up.
weekend.
That's all I know.
Yeah.
So it's going to be a shock to the system, like a huge shock to the system getting back into work. But I think it's going to be good for me to actually create a bit more of a morning routine and an evening routine, just because I have no willpower at the moment. I feel like I need to get back into it. So,
Yep. That's good.
yeah.
It's good.
Yeah.
It's good for a schedule. What's going to happen with your running though? Because if you're doing 2 cycles every day, and then a
Yeah,
run in the
that's-
evening, you'll be. Whew.
It's a good question. I don't really know. I do want to continue doing it. Maybe I won't cycle every day. Maybe I'll cycle like 3 days a week and drive the other, and then come home and jog. I'm not really sure yet. I've been enjoying it, so I do want to
Yeah,
keep
don't
it
want
up.
to stop. Don't want to
Nice.
stop at
But,
all.
Yeah, I say I've been doing home workouts this past week, and that's been fun.
Nice.
I've
What sort of
absolutely
things?
destroyed my arm, to be honest. Like I physically can't bend my right arm out fully. It's been so sore
Nick.
today. So
That's not the one.
So is your right arm
No.
weaker than your left arm?
I guess it must be right. I've got bad form on my left, one or the
Yeah.
other. So, which is probably I've got bad form on my left and not doing the exercise properly.
To be fair, that was really bad. I went to play basketball one morning because that's what I used to do last summer when we were stuck in lockdown. So I went down at like 7 in the morning or something. Next day, right, my arm was so sore. My bicep like hurt so much, and I was like, I'm not lifting anything. I'm literally just throwing
Yeah.
a ball. It's because the workouts have been so lackluster recently that was painful. for me.
Any exercise.
Just
is
any
just
exercise,
killer for your
anything that
body, isn't
wasn't
it?
just like eating was
Opening the
hard.
fridge door.
Opening the fridge, yeah. Washing up's probably the most exercise I've been getting.
Oh,
Oh, I think you
Getting
guys
those
are
stains
you're
out your
getting
mug.
old, boys.
No,
Yeah.
I'm just in that lockdown sadness.
Yeah, just had a flashback to when my mum injured her elbow from throwing a frisbee for my dog.
Oh no.
Oh, that's hilarious.
Terrible injury.
Thing
Yeah.
is, that's what's coming.
Yeah.
Enjoy.
It's already starting. Pulled my back muscle sitting on my chair 3 weeks back, was it? So already starting. Yeah, so I guess we will transition into our topic of the week.
And slowly
Insert
stumbled
jingle.
there.
Insert jingle. Yeah. You don't have a jingle.
Don't have a jingle.
But yeah, as I said, our topic of the week is design for manufacture, and I guess like all the best designers, all the best industrial designers as well, they have a wide knowledge of manufacturing techniques and how to design for actual manufacturing and how to actually get a product from concept to market. So it's very valuable to understand, even if you don't have to do it that much as an industrial designer, because you might design something and then give it to the engineers, right? And then it's the engineer's job to then change it so that it can be manufactured. But I think they'd probably love you if you could give them a concept which makes relative sense of like, okay, I've considered this is how we're going to make it. Now we can go forward with it. But
Say it's
I mean,
something that should be involved
Yeah.
in everything, really. I mean, apart
It
from like
just-
the initial stage where you're just looking at ideas, the second you've got
Yeah.
a half decent idea, you've got to be thinking about it, really.
It's just a step in the design process,
Yeah.
and I would wager that all good and successful designers, even if they're just not like when they're doing concept designs, but industrial designers, they all will have that in the back of their mind. For example, you
Yeah.
might just have some part that's a plastic part, and then you need to have a think: how is this actually going to be made? If this is going to be injection molded, there's some very serious limitations to the sort of shapes that it can be. Or it's one of those things, because if you're at these big companies that are trying to create things, real life things, then you can't just be going and saying like, I want to make this and it's not feasible. You know what I mean? I'm sure all good designers do consider this as a very important step in the whole process.
Absolutely. Just having the knowledge can help in so many situations, because I guess if you are talking with manufacturers overseas, if you know that this can be manufactured in this way and they're telling you no, we can't do it, you're like, well, I know it can be done, and now by you not being able to do it, I'm going to have to change the design. And then kind of it might even ruin the whole design. Like, so maybe they can't do like a certain draft angle, or maybe like a certain radius, or those are things that okay, they can do it, it's just this factory and I'm not changing the design. They need to get the facilities, or we need to look elsewhere. So it's very valuable even when it comes to kind of negotiating with the factory. If you didn't know, they just go, we need to change it to do this, you just go, okay, fine.
Yeah.
And then you could destroy the kind of the spirit of the product, I guess.
So I think it's one of these things that we sort of learn the theory behind design for manufacture, a lot of it at uni.
Yeah.
But we're never really taught how to implement this, or really the reasons why it's good. And this is something I learned a lot more in my job. I am a design engineer, so again, like you said, if you're an industrial designer, you might not be doing quite as much as in-depth from start to finish as I'm doing. But in my role, it's such a huge part of the design process, because I always come up with sketches for a unit that I'm working on, and then I could in the next 5 minutes just model something up and be like, yeah, that works. Whereas when you're going through each part, working out how each bit is going to be made, you then end up most of the time coming up with a far more efficient design. And especially if you're working at a very small company like I do, it becomes the biggest place to save a lot of money when it comes with the design, and that is then when you get more product.
Very true.
You get more profit, and you're then doing your job a lot better. So it's one of those things. So the benefits of design for manufacture come in many ways. It can come in I know it's technically a different subcategory of this, but designing for assembly is where you're sort of trying to prioritize the design of a product so that it is as simple as possible to design, to assemble, to put together. This is actually something I do a lot in my work, because we were finding that in the costs of when we're making a unit, a lot of the profits of that are actually taken out in the man hours putting the stuff together. So that's a huge place where people can save money in a company. If your product is a lot simpler to put together, then you're then making more profit based on they can put it together easier, or there's less mistakes being made when they're being all put together, and that's super important. And then the other side of that is if you can make something that's easy to put together and then it's easy to manufacture. So I work in a lot of sheet metal. If you have these super complex parts, you're then basically putting the ease and success on that product on your manufacturers. And if this part is super complicated, and then your manufacturers struggle making it, you then could have parts coming to your factory that don't pass QA, that they just don't work. They're parts basically failing, they're not working properly because it's a way that the manufacturing has been done in a way that isn't right or the best way it could be. So these are all basically just ways that you can improve your design, and it's very important to do this sort of step to go and refine all these bits, so you get a lot less parts going back to be reworked or any of these things. So this for coming from someone who's a very small company, well, this is the majority of the design process. Like you come up with the concept, and then the rest of it is how can we make this as cheap and as efficient as possible without just wasting money on parts that aren't necessary, and all things like this is such an important step of the whole process.
Absolutely. I know when I worked in my last job designing stoves, there was this air assembly that I had to design, and initially I designed it in such a way that it wasn't like its own assembly, you had to attach it to the stove altogether. And then in speaking with the guys at production, they basically said, if you make these small tweaks here, we can put the stove to be shot blasted and painted, and while that's happening, we can then assemble these units, and then we can just bolt it on the bottom, and we can save so much time rather than having to wait for it to be shot blasted, painted, come back and then bolt it on. They can literally do it all, do it in like an efficient way, and it saves them so much time. So there's so many ways that you can improve a design, and if you're saving like 20 minutes on the assembly line, that's huge.
Yeah, definitely. And I guess yours is slightly different. You have a slightly different experience with this from your job designing stoves, as I do in my job. Is we don't manufacture stuff in house. We usually had a shop where sheet metal was being folded and welded together and stuff. So I guess you could speak directly to the manufacturers to be if a part wasn't good to be made. Whereas we have a really good relationship with our manufacturers, but they make what we tell them to make at the end of the day. They might have some issues if they're like, look, we can't do this. But generally, if the part isn't very good, then they're still going to make it, really. And if they draw it and make it to the drawing, we can't. We then have to just redesign the part and tell them to make a different part if it's wrong. Like often what finds out, if you have a part that hasn't been designed too well and it doesn't fit properly or whatever, then you end up you're just filing it. We're just having to go at it with a file or a saw to make it fit. Yeah. And these are all sort of things that are like, that's all based on the tolerances you put behind things and understanding the processes of how a part is going to be made, and how that part, if it's made in this way, will it affect the end product or not?
We even had situations where anything loose on the stove essentially can be a spare part. So if anything fails or breaks or bends during installation, you can then order a new part. And there's even times of when you have to get your chimney swept and things like that. Sometimes you have to remove parts, and if it's not accessible for for the chimney sweeper or the installer to even remove a part from the stove, that can be what you call like a potentially bad design. You need to include these people in your thought process of like, okay, if this guy's going to have to reach underneath, I'm going to make sure the gap at the front for the legs is going to fit like a guy's arm so they can even get under there, and give them kind of allow them to even see how to like unscrew something and things like that. So there's a lot of factors in terms of like who you need to think about when you're actually designing the product. It's not just the customer,
and it's not just the just the shape of it. Like you said, like
yeah.
a lot of the part for my things I design at the moment is, you know, it's a lot of electronics being mounted to a metal frame sort of thing, and you need to consider all the things like, will you be able to fit a hand in there? Can you plug or unplug this thing? Can you remove just this one part if this bit of electronics fails? So like all things like that, like the considerations behind your product are actually so important, and these are something that happens so early on. Like, you know, if you need to be designing something, you need to have all the components that go in it, so you know how everything works together. This is all. I mean, that's more general design considerations, I guess. But it all goes into the same thing. As like, if you can't, sometimes we've seen things where bits are put together and you can't even get a spanner in to do up a nut. You know, there isn't even you can't even get it in there. Like, you know, it doesn't work. So there's so many things that are very important with these sort of things, and they all can be solved super early on in the process, and they should be solved early in the process.
I think like there's certainly one thing that I learned quite quickly was I used to want to design a new part for every product that I did, even if a part existed on another product, even if the same part existed on another product. Basically, what the result of that would mean that there would be an extra space on the shelf for the same part with a different name.
Yeah.
And suddenly it's like you're taking up like the warehouse space, and that's costing money because something else could go there.
There's a lot of
it's
things
really,
with
really interesting, right?
naming parts and stuff like that, because the way we do it, if the part is backwards compatible, so if this would fit any new or old version of that unit, then we just make it a new version. So, for example, we've just changed the bolt holes on a unit I designed, and I then added in a support plate. So I had to have the holes for the old holes, and then some new set of holes to where we moved them. So if they went on site to put this support plate in, and they realise it's the wrong version of Kiosk, it's an older one or a newer one, they could then be like, oh, cool, it doesn't matter, it fits in either way.
Yeah.
So that's how we know to up issue. But then if it's something that isn't backwards compatible, or it's you change something so much that it wouldn't work, then we make a new part number. But that was something that I struggled with so much, just like getting my head over, like, wait, should I do it now? Like, which one should it be?
So
that's
something. If you work at Lego and you make the new Lego, cars or buildings, whatever, you have to try and use the bricks that already exist. Like, I think there's one that I've got, which is a James Bond car, and they use one of the Western pistols as like a hinge.
Really?
Yeah, it's crazy. Like, because obviously they don't want to make a new mold for a new thing if they don't need to.
Yeah.
So
That's a lot, yeah.
Oh yeah, the mold costs would be expensive.
So yeah, that
just
really cracked me up when I saw that.
That's amazing. I love the fact you even noticed that.
Yeah.
Yeah, because we watched a lot about Lego when we were at uni. I don't know whether it was one of the guys there. We went to a toy fair where one of the Lego guys spoke. Not sure whether it was him that said that there's like a competition where you want to use as many old parts as possible, or whether it was like you said, you get a bonus if you don't do it or something. I've definitely heard that somewhere. That the creator gets some kind of money goods for making new parts.
I guess. Yeah.
So Andy, your job currently, you are not designing as such. how much from uni do you know of designing for manufacture? How much like practice do you have in this sort of stuff? Do you feel like it was covered much in your course at uni, or was it?
We
not
obviously had draft angles of things. That was always a massive thing. But again, we weren't told like what kind of draft angles to use. We were told one degree is good for students, and then anything else you'll learn on the job. So for me now, I've not had a design job. I don't know what draft angles to use. I mean, I know when to use them, like what way to put them, but that's it.
That's
so that's something
another
which
thing,
wasn't really
actually.
covered well, huh?
Just saying that's another thing. At uni, they absolutely love injection molding. They don't go into any detail for any other sort of manufacturing process at all. It's because I was doing sheet metal. All I knew is a sheet starts as a flat thing.
Yeah, so
And you
it's
fold
all,
it.
it's all plastic, isn't it? It's all
Like they literally only focus on injection molding. So
everything.
add a good old draft angle in there, and we literally used to do so much stuff that would just be injection molded. When you realise it's like the most expensive manufacturing process unless you're doing mass production, which is very strange. Especially as most people won't be going to big companies that will be injection molding stuff. But yeah, I don't know. It's just one of those weird things that I don't think I definitely wasn't prepared for sheet metal at least. And I think we were generally prepared for a lot. Like, for example, even that draft angle thing, you just just whack one degree in, it's fine.
Yeah.
At least on my masters, they gave us a calculation, which gives you an angle based on the height. Because the higher the angle, higher the wall, the more angle you should have. Because
so it makes
friction.
sense. I mean,
But
that whole thing is like, oh, it's fine. You're a student. It's like that's when you're in like the final year of your
so backwards.
of your degree, and it was a model. It was a module called advanced modeling. It's like if it has the advanced thing in it, you should be doing it exactly as it is if you were actually making this, not just it's fine. You're a student. You can get away with it.
Yeah.
You wouldn't be as shocked when you actually get into industry, that's for sure.
Yeah, and then you're just doing 1 degree for everything. It'll be fine. I'm a student.
Because Andy, you got to model some molds in that, didn't you?
Yes.
In your course, which we didn't do any of that in ours.
Yeah, so that
which
was
seems really interesting.
That was for injection molding as well. That's what I was thinking. Yeah, it was injection molding and plastic everything. It's
It's just like the most glamorous in terms of making a product. You can have it injection molded. Like any good example of a well designed product these days is all blooming injection molded. All of them.
It's probably what it is.
For example, my company, I've designed many injection molded part. They never get approved because the molds are too expensive. So we just do the metal versions of them.
Yeah.
But we've got our main product is injection molded because it's for UK prisons. So there's a lot of them, and there's a lot of the units being made. So it's then fine. But if your numbers aren't high, it's not worth it. But yeah, it's just very strange how that's the main focus when most companies are just not injection molding everything left, right, and centre.
Yeah, I would say it's probably one of the most important ones to learn and understand, though, because I guess it's quite transferable if you're kind of looking at some other manufacturing techniques.
It's one of the most flexible, I guess. You can design the most amount of things, and also it's the highest risk if you get it wrong. So I guess teaching us is also good.
And it was two extremes, isn't it? Because we were either doing that, which is for proper mass production stuff, or one-off prototypes of, woodwork stuff. The one-offs rather than the mass production. So I guess it's like either end of the scale. So that makes sense. But I don't know whether the lecturers didn't talk to each other about what they were doing, or whether the course is just set up wrong, or or what?
Yeah.
Because it shouldn't all
Or
be
they
about
just don't.
plastic.
They've not really been in industry and they don't have a clue.
I
There's
do
that as well,
think
right?
I do
That's-
think a
that's
lot of
also
our
something, yeah.
lecturers they have not left a university.
Yeah, it's been
Oh, they've been there for
academic the whole
years, yeah.
time. hasn't
A
it?
lot of them have just only done that, I feel. There's obviously some which you know have actually worked in industry to some extent, but there is a lot that, you know, they're just academics and they're just there
Yeah.
for the rest of their life. But
Yeah, because we for stoves, you do quite a bit of casting as well, and that mainly sand casting just because it's
yeah,
cheaper. But that was interesting of having to design stuff for casting, and I didn't really have the knowledge for it. And like, just an example, I guess, is if you don't have the knowledge for it, you have the possibility of adding lots more material where you don't need it at all, and then the more material there is, the higher the cost is. And
so
then
many
there's
things
also
with casting
chance
can
that
mess you up. So many things can get everything wrong. Like if you don't
Yeah.
have, obviously depending what material, I assume you're doing it in cast iron or iron.
Yeah.
So for example, if your design wasn't a constant thickness, you can have some really weird shrink issues. If you have too many sharp corners, they just won't get filled, especially in sand casting where the walls are pretty rough in comparison.
everything was rounded, like there was a fill on everything.
Yeah, you have to, otherwise
Literally
air gets
everything.
trapped in it and then you just have a massive missing section of your mould. Yeah.
Well, that's something that would have
Yeah.
been fun to do for a uni thing. Even if we could have done it
Easily
in
could've.
groups, groups of 5 or something, all have something casted, would have been cool. Like
You can easily
Yeah,
do
it
it,
would be really
especially
nice.
sand casting. You can
So,
do that in
yeah.
a day.
some
Like the one I did was a easy project, the plant pot, and I just 3D printed the molds. It's not a. I did it in I modelled it in like 2 nights or something. It's not like that couldn't be a bit of coursework.
so that's a full term of coursework. That is
It would be, yeah, it would be.
2 nights.
I know, like, one of the doors that I designed, we originally decided that it was going to be like rounded on the front. So we sent that off, the mold was made and everything, and then later on down the line, we decided that we wanted it flat instead. And they had to like machine the mold. It was still cheaper to do that than to make a new mold, but they had to machine the mold to try and make it work and things like that. It was like, God, like if they just had that insight beforehand, but that could have been a mistake because you could make that as a mistake as well, and then they've got to then machine the mold and try and get it working. So if you do need to make a revision on it, it's expensive, right?
You can't add stuff to the mold as well because if they had changed it by machining a mold and then it went wrong, then you've actually just ruined the whole mold.
Have to make a new mold now. So.
Yeah.
So it was really, really interesting.
Those sand casted parts you did, were they what sort of quantities? Were they high quantity or low?
Like in terms of like how many was going to be manufactured. Or,
Mm.
I mean, I don't have a number to be honest, but
Was it like
the stoves are mass produced, so there's a lot of them.
just sand casting is you can't reuse a mold that many times before it starts falling apart. Is the thing I was just wondering.
Okay. Yeah, I assume like, but
I mean, I'm sure
manufacture for stoves. I suppose it's probably within the limit before they have to make a new one. I'm not
I
entirely
also
sure, but
assume the man who did that knows a lot more about it than me and knew that sand casting was entirely fine. I was just curious.
yeah. But it's like, it's just an example of, like, I guess if you don't design it properly, you can end up having to pay loads and alterations. Just changing
That's
the
that's the
that,
main the main reason behind the whole concept of design for manufacture. It so you have a lot higher chance of having a successful product when you finish the product. So once all the parts have been ordered, it's far more likely you're going to have a successful product, which basically lowers any cost in reworks. So a lot of the time, actually, since I've worked with the company, we've not sent any parts back that were designed wrong, which is good. But
That's good.
it could be like I'd need to drill a hole bigger, or
Yeah.
we've done bits of that, filing something so it doesn't collide with something else. But if
Mm.
it's a bigger issue, then you have to send it back to the metal workers, especially with a company like mine where we don't really have the facilities to do any proper work.
Mm.
That costs so much more money, and especially time. If you're working a really short lead time and you're assembling stuff and things don't work, then you can be really, really messed up with that, which is
Mm.
what you want to avoid.
Yeah, that would be the
As-
biggest thing on our prototypes. Would be like if something's gone wrong, we'd probably just have to drill out the hole, re-tap it, and then like re-tap the
But that
like the
that all
assembly
costs
part
time.
and then bolt it back on.
That all
Yeah.
costs time, and you may not be thinking about that, but all that time that these workers are working on putting one unit together, that gets taken off of the profits of that. And sometimes, if you're working on it for hours, you realise you actually made a net loss if you take away
Yeah.
the salary of, not the salary, but there'll be a rate.
rate or
There's a
whatever.
rate of your assembly
Yeah.
time, which is crazy. But yeah, I mean, like you said, like you do that in your prototypes. My company doesn't do prototypes. I said this the other week. We
Yeah.
our first order of it is the prototype. So having sometimes you're like looking at a model, just staring at it and being like, right, is there anything that could go wrong? And this is it's just such an important step because we can't afford for it to go wrong. So you've got to get this thing right first time. Otherwise, what you're going to do? Because the client always wants it yesterday anyway. So
Of course, yeah.
if you get it wrong and then you have to wait another 4 weeks for a new bit of metalwork to come, then you're kind of ruined for that. With that client, at least they probably won't come back.
Yeah.
But yeah, especially like you said as well, if a company's very limited in money, they don't want to be paying for reworks on a mold or anything like that. It just costs more money, and it's just generally not good.
Exactly. And I think there's the other thing that it was briefly discussed at uni in terms of using fixings, right? So having your list of different fixings that you can use.
Yeah.
And I believe we modeled our own screws and things like that. And which is completely unnecessary. Like, you don't need to do that at all. I feel like every CAD package has like a database of fixings you can just use which are standardized, right? And it's like that's something that I feel like isn't taught at all, because there's so many amazing fixings and also like different washers which make a huge impact on like how the mechanism feels and things like that. It's like, this is so important for actually like designing some things that are not talked about at all, at least when we went to uni.
Yeah, I mean, maybe if because I know our courses basically should have been called design engineering. It had the maths exams and things like that, and the material science. But you would have thought it would have been told more. Like maybe mechanical engineering were like had a unit on fixing stuff. Probably not, but like maybe they were shown more. But yeah, we definitely should have.
Mentioned. It could have.
Yeah.
It literally could have just been mentioned, like rather than us making our own screws. Like I don't know. They could have literally just said, "Oh, for this, can you choose the screws that you want from this list?" Or something.
Yeah.
Or like here's a list of everything. Do whatever you want.
Yeah.
That would have been nice. Takes
Or
like
even just mention
5 minutes.
Look it up yourself. Use a screw that
Takes
Make
exists.
sure
5
you know
minutes.
this when you go into industry, because you're going to be a fool if you don't.
Pretty much. Yeah. I
Like,
remember.
you can come up with a concept, and then like the engineer would be like, okay, like how do these two parts fit together, and how are they secured? You're like, I don't know, no idea.
I had that my first day working. He was just like, because I didn't really know what a stud was or a standoff was or anything like that. Which is a stud is basically the equivalent of welding a screw to a face of sheet metal. So it's just basically a threaded bar that you can then bolt stuff to, but it's welded in place. And then a standoff is like the female version of that. So it's just like a a spacer with thread inside, so you can screw into it as well. But I remember my boss talking about these things, studs and flange nuts, all sorts. I didn't have a clue what he was
Like
talking
what?
about really.
Yeah.
But
It's
I
certainly very
remember
important.
the only time we were actually told about any sort of fixings at uni was in first year with our technical drawings lecture, because we did a lecture on doing hand technical drawings and we had to draw some nuts.
The joys.
Oh
yeah.
yeah.
That
Wow.
was first year,
I remember
first
drawing
term.
something.
I remember him because we were laughing at flange nuts. That's the only reason I
Oh,
I
dear.
remember it. That's crazy though.
Hilarious. As I know we had the module where we had to design a plug for manufacture,
Hmm.
and we did have to have a screw,
I nailed that
accessible screw,
one. I nailed that screw.
to like fix the parts together. And it's just like it's funny, I guess. Like it seems so obvious, but also you
It's
don't
not
know.
obvious if
like,
you're not told, yeah.
It's not obvious if you haven't been told, right? And
I
like,
think-
if
yeah.
you even just said, yeah, you need a screw, it's like, okay. Right.
It just feels like that shouldn't be the sort of thing that you had to look up yourself and find out, when it is literally how everything is fixed together.
Yeah.
It's how anything is assembled.
Mm-hmm. Exactly.
I don't know, it's just, I don't know. Maybe all three of us missed something, but surely not.
maybe.
Unlikely.
Surely not.
Unlikely.
I think that the other thing which, at least I do, it wasn't covered in ours. It might have been covered in yours, Andy, but is even like the file types, like for like sheet metal and like step files, and like how you even send a file off to be manufactured
no.
or laser cut, and all this stuff is like, it's pretty, yeah, it's essential to know. And you need to, you will get told in industry, but at the same time you need to know, okay, I need to send this off to be laser cut. What format do I send it in? How do I even arrange that? Like, how do I do a sheet metal part? And there's also like what file was needed for who, and what, like, I feel like
Yeah.
that's been quite important. No,
I
it's
agree.
basic stuff once you've been told once. But I feel like it's still not covered at uni at all.
It'd be nice to not have that embarrassing. So what do I do here?
Mm.
What do you
Yeah.
mean by this? Not
Yeah.
having to do that would be kind of nice if I paid how much I paid to go to university, but that's fine. But yeah,
I mean, you learn like the
yeah, you learn, and
the
you'll remember it when it
essentials.
is embarrassing, I guess.
Mm.
But
yeah.
yeah, but I think is that everything we wanted to talk about in terms of design for manufacture?
Yeah,
It's
I
probably
think
just
so.
I guess the overview is it's a part of the design process, a very important part of the design process
Yeah.
that happens very early on in the process, before the sort of, well, it should sort of be going on before the sort of heavy engineering of the actual design, and sort of go into the considerations and work out exactly what could go wrong with the product, and it's a way to sort of minimize any sort of issues you would have with the final product. And it's just
Yeah.
and it becomes very, very important in these, like, especially in small companies who can't afford to have issues with the design. But it's obviously still very important in bigger companies. There might be a person who does
If you've, like,
entirely that
manufactured
though.
millions of a product. and
Yeah,
it's
you don't
wrong.
want something wrong. Yeah, if you're paying
But-
50 grand for a injection molded cast, and then it's your fault because you didn't consider something, that's a bit
Yeah.
of a problem.
Yeah, but I think like these, I'd say probably for most designers at least, like these small details, the things that no customer is going to see, like no consumer is even going to see that you've made this decision to add this bit in a part that no one was going to look at. But it's all these small things that you end up loving about the design. You're like, oh, they don't know actually how much love I put into this, like one part.
The
of this
thought behind
product,
everything.
right?
A lot of
Yeah.
the things that a lot of the time I spend on stuff is actually behind the whole, like, how something might be put together, or when I'd work with my boss, we even were thinking about the order things are going to be put in and assembled in, and all things like that, all just try and make it, especially for our work, as easy as possible for production to put together, so there's less and less time remaking the whole product when it doesn't pass QA because it's been put together wrong. So it's all things like that are so important, but no client, no person using the product will really notice these things because a lot of it's all internal. But if they aren't there, you get a lot of issues in the product.
People will notice then.
They'll definitely notice when it's not working properly.
Yeah, that's the thing, isn't it? Like, if a product works well, people don't talk about it at all. Like, they just think it's how it's supposed to be, and then as soon as there's a mistake, they're like, "Oh, this is awful." It's like,
we get that.
Suddenly, that can.
We get that an awful lot in kiosks. If the product works fine, it's fine. If the software in the kiosk doesn't work, they blame the kiosk manufacturers, and we don't even do the software. Like, come on.
It's not our fault.
But I mean, even if they're kicking the unit, they won't be able to break it. So jokes on them, I guess.
Tested it.
Yeah.
Yeah,
I think it's.
I think that pretty much.
Yeah, I was gonna say, do you want to wrap up, Nick? Any more than I did, or?
I feel like I've got nothing else to say, so thanks everybody for watching this episode of the Great British Design Podcast, and it's been a lot of fun, and thanks for sticking around. Cheers, everybody.
Thank you very much. Bye-bye.
Bye.